Hello, my name is Llambrich, and I will guide you through this tutorial about Easy-Amanida, a meta-analysis for metabolomics data. As we know, meta-analysis is the statistical combination in a single estimate of results from different studies answering the same question. This is the high level of evidence in clinical applications. And one of the omics that is emerging and nowadays is more hot topic is metabolomics. This is the study of the endogenous and exogenous metabolites in biological systems. For metabolites, we understand the small chemical compounds that are in our body or in other organisms. For the characteristics of these studies, the number of possibilities when we do a metabolomics studies is really big. So it's 3 times bigger the number of metabolites than the genes that are in the humans. For that reason, all the meta-analysis that we found in metabolomics, that there are few, looks like this. So this is not what we expect when we see a meta-analysis, as the one is not like completely quantitative. This is about counting. So we only take in account the trend of the compound. So if the compound is upregulated or unregulated in the group of our study. But what we are looking in a meta-analysis, we want to improve precision by merging different studies. We want to settle controversies and answer these questions. In this case, we don't see if we have a lot of controversies inside a compound or a metabolite, only if the controversies are equilibrated. For example, citric acid, the first one, which is significant, if we check all the studies independently. So here, what we see is the trend divided by upregulated in red and unregulated in blue. What we see is there are some studies that show that this compound is upregulated, where all the others show this compound unregulated. One effect that we cannot see in both counting. Other problems that facing metabolomics to perform the traditional meta-analysis as set in Correig is the type of data that we are used to disclose in the studies. So for a meta-analysis of continuous data, which will be the type more appropriate for metabolomics, what we need is the mean, the standard deviation, and the number of participants. And what we have in metabolomics, which is an omics with not standardized guidelines for reporting the results, is that standard deviation is not disclosed in the studies. So we cannot apply the traditional meta-analysis. The only option that we have is to perform with the raw data. In some cases, because in some others, the raw data is also not disclosed. But for the dimension of the data, this is time-consuming and also a lot of cost computational. For this reason, we select the 2 metrics that are more disclosed in metabolomics to perform the Amanida solution of meta-analysis. We are in clinics, so we usually compare 2 populations, or disease group or case group with the control one. So what we want to see if our 2 populations are different within them. To set the difference, what we use is the p-value and also the fold change. So the p-value is statistical significant, and the fold change is the biological change. And we want this combination to know if they are different or not. So the Amanida meta-analysis use these 2 metrics to perform the meta-analysis, combining them. For the p-values, we use a variant of the Fisher method to combine between the other studies, and these p-values are weighted using a gamma distribution by the sample size of the different studies. Then fold change is first logarithmically transformed, and then averaged also using the weighting of the sample size of the studies. With both these metrics, we perform the analysis. So what we need to perform the meta-analysis? First, do the study selection, so a systematic review or the choice of the researcher. So our recommendation is to follow the PRISMA guidelines for systematic reviews to be sure that we are including all the studies that are published about that topic. For this, we will use identification of studies via databases, also previous studies, and include also new studies that check if all of these studies meet the criteria that we set. For example, a certain number of samples in each study or certain technique used. Once we have the study selected, we will gather the data that we need for the meta-analysis. In this case, we will obtain the compound ID, disclosed in the studies, the number of samples used, and then the two metrics for the meta-analysis, the p-value and the fold change. Before applying Amanida, this is an optional step, but highly recommended in metabolomics, as also different compounds name can be used in different studies. So we want to combine all the results, and we want to be sure that we are combining the same compound. So recommendation is to translate the different nomenclatures from the same compound to a unique one. So this is a step that can be performed directly in the Shiny app or by the researcher. It's your choice. What the Shiny Amanida app does is searches the compound in PubChem, because this is the biggest database of chemical compounds. It's computer programming accessible, and you have multiple IDs of other different databases to compare. So when you put the component ID, you don't have to worry about the nomenclature problems using Amanida. So let's make hands-on. So we have our data table with information of the different studies. It can be a text, it can be an Excel file, it's not a problem. And then we can perform directly the meta-analysis. You can use the R packets in CRAN or the Shiny app, and you will get the same results. So we go to the Shiny app. So here we have the Amanida line page of the Shiny app. We have disclosed an example dataset, which you can load in the left panel. Here we search for our dataset, we load it, or if you want to use, you can also use the example dataset that is already in the app. Once the dataset is uploaded, we select the quantitative analysis, which is the Amanida meta-analysis. The qualitative analysis meta-analysis is the bot counting that we showed previously. In this example, we won't use the compound ID search because it's time consuming. If you want to try, it's not a problem, but it will take a long time. Then we match the columns in our data set to the elements that we need for the meta-analysis. First, the compound name, which is the ID. In this case, we see the chemical name of different compounds. Then we move to p-value, the fold change, and we also include the sample size in each study, all of these numerical values. And at last, we include the reference where we obtain each compound. So each row belongs to a metabolite in a different study. Once we have this data, we can see the previous information. If it's all correct, then we press in the calculate button to do the meta-analysis. If there are any row with missing values or empty values, what we will see is that is marked in yellow. So these rows will be skipped on the meta-analysis. We need all the information to perform the meta-analysis. In this case, we have one row that it's been skipped. So, to see the results, we go to the quantitative analysis tab. The first tab that appears is the graphical results. It is in format of volcano plot. And what we see is on the horizontal axis, the logarithm of the fold change combined. And in the vertical axis, the logarithm of the p-value combined. Each point corresponds to different metabolite with the results of our information. The most significant values will be found in the upper extremes, in the right part, and in the left part. In this case, we see one tone-regulated compound that's significant, which is the puric acid. If we put our mouse, we can see all the information. And if we move to the upregulated part, what we observe is that we have the acetylspermine that is also significant in this data set. What we are observing here is data from colorectal cancer patients. So we are comparing urine samples, metabolomics analysis in colorectal cancer and in control individuals. All this information is also in results in a table format where you can choose how to sort it. If you want to sort it by the fold change, like how metabolite is found in more studies, in this case is the citric acid, or directly search here for one that you are interested. So, for example, the puric acid, which we see that here the results are without logarithm, so the p-value is significant, but the fold change is not significant after the combination of all the studies. If you have selected the include compounds IDs part here, what you will have is in results table all the information about other identifier of the compound. So you will have the human metabolite ID, the PubChem ID, among others. So you have the complete information of every entry. Here we only see the numerical values, but we will also want to see if we have controversies in our data. For this, we go to the qualitative analysis tab, which is the vote counting. Here is the traditional vote counting, where you can select the cutoff. So you can select the cutoff in all the different tabs that we are showing. And then we have the explore plot to see if we have truly discrepancies in our results. So here in red are the times that the compound is found upregulated, and in blue, the times that the compound is found downregulated. So we see that there are a lot of compounds that have discrepancies. And we know, for example, puric acid, the one that was significant unregulated, that has consistency among all the studies. So this show that the results of the meta-analysis are robust. In case of we have some metabolite, some compound that is significant in the meta-analysis, but there are a lot of discrepancies between the studies, we will have to look in deep. Why are these discrepancies in different studies, and why are the values so significant? So we will trust first the compounds that are in all the studies in the same trend. So you can download all the different plots that we are showing on the panel that it appears at left. You press the download button. Also, you can download the table, the volcano plot, where you select the threshold that you want. In this case, we have the convention, but you can decrease it or increase it, so it's not a problem. And at last, you have the report tab, where you can download all the information in a single file with all the plots and all the tables. So you press in the download the report when you have selected the different thresholds that you want for your data. And what you're obtain here is an HTML file with the information of the meta-analysis. So first, what you observe is the different components, the raw data that you disclose. Then you have the meta-analysis, the quantitative part, data table with all the results. If we have an asterisk, a mark in the name, this means that it's significant. Then you have the graphical results in the volcano plot format, and also the explorer plot to see if there are discrepancies between any of the different metabolites. And we also include the bot counting if you want to have more information. So this is all. I hope that you have enjoyed this meta-analysis. I have to thank all my collaborators, and if you have any doubt, please stay in contact with me. Thanks.